Good evening all. So now today we will begin with a new chapter, which is on heat. Thermal physics or heat is one of the chapters which many students I see has been facing problems. The major problem that I see here is that they often get confused with energy and temperature changes. So I thought, let me start from the very basics, taking up a problem from every concept, then design a problem for a concept, and then solve it and look at where students have made a mistake. Again, misconceptions. Okay. So towards it, the first problem that I thought of was, so there's not a problem asked anywhere. I just made a problem on my own. So it reads, molecules leave a boiling liquid from a vapor to form a vapor. Okay. So usually when we heat a liquid, the temperature of the liquid rises. And after that, when it goes to the boiling point, and after that, when you still keep on supplying energy, the liquid turns into a vapor. The vapor and the liquid have the same temperature. Okay. What is the change of the average potential energy and the change of the average random kinetic energy of these molecules when they move from liquid to the vapor? This is the question. Now the options here are average potential energy and average kinetic energy is given here. And just a moment. Yeah, okay. And these are the options. Potential energy increases, kinetic energy increases. Potential energy increases, kinetic energy no change. Potential energy no change, kinetic energy increases. Potential energy no change. Kinetic energy also no change. Now, so before I am giving this talk, I just asked a few of my students what could be the answer. The immediate response they thought they gave me is that since they said you are supplying some energy. See, molecules leave from a boiling liquid to form a vapor. When you say there's a boiling liquid to form a vapor, which means what? Boiling in a boiling liquid, the molecules are very closer to here like this. They're very closer to here like this. I mean, where is it? Just a moment. My pen is not writing properly. Okay. So you will get one molecule here, you get another molecule here, you get third molecule here, fourth molecule here. Okay, or maybe I'll write here. Okay, so here itself. Okay, there are several molecules which are closer to each other in a boiling liquid. In a vapor, what happens? The molecules are farther away like this. So one molecule is here, other molecule is here, third molecule is here, and so on, which means the distance between them is increased. Okay. Now, the vapor and the liquid have the same temperature. What is the change in the average potential energy? We know potential energy is due to, it's a function of the distance between any two molecules. And we know that the potential energy is proportional to 1 by r. You already learned this, right? So as a result of this, when the distance increases, definitely there should be a change in the potential energy. Accordingly, mathematically, if you see field, when the r value increases, the potential energy should also decrease. But there's no option for decrease here. Then maybe, since we can always think potential energy is negative initially. So as a result of it, negative potential energy increasing is equal to the magnitude increase. So you can say one of them is right. Okay, so definitely these two are incorrect. We can very clearly say. So it should be either A or B. And then they also said that, sir, when this is happening, and as a result of it, kinetic energy, total energy increases, kinetic energy also increases, the particles are moving, and hence A should be the right answer. Okay, A should be the right answer. Now, why A is the right answer? Because this is correct. This reasoning was correct. This one, they thought this is the right answer. The reason is because when the molecule turns from a liquid state to a gaseous state, the molecules here are not standing anywhere, right? They start to move randomly in every direction. When they start to move randomly in every direction, the speed of these molecules are larger. And as a result of this, definitely the kinetic energy should increase. When speed is increasing, kinetic energy should increase. That's why they thought A is the right answer. But A is not the right answer. Okay, this is a misconception. So why A is not the right answer? The reason is because, you read the line once again, the vapor and the liquid have the same temperature. Now, when you have something as the same temperature, then its internal energy is constant. Its internal energy is constant. Its internal energy is constant, or change in internal energy is equal to 0, and hence temperature is equal to a constant. Okay, when the temperature is constant, we know that temperature is directly proportional to velocity. So as a result of this, you see, there should be no change observed, okay, in the random kinetic energy. The reason is because when temperature is constant, velocity should also be constant. If velocity is constant, your half mv square should be constant, and hence the right option should have been option B. I hope you understood this topic very clearly. So whenever there is a change in temperature, the velocity of the molecules will increase. Whenever there is a change, this change, if it is larger, from a lower to a higher temperature, the molecules move faster. Okay. When the temperature reduces from a higher temperature to a lower temperature, the velocity of the molecules reduces. Okay. Now you can also ask a question saying that if the temperature keeps on reducing, if I keep on reducing the temperature, okay, and is it possible that I can freeze the molecules? Do you have an answer for this? Yes, of course. If you start reducing the temperature from a given level to a threshold level, at that point you observe if the molecules are not moving, that is a place where you say the molecules are completely frozen, which means what happens? The molecules are not moving, and hence this is the state where you call it as a superconductivity. Okay, the state of superconductivity is achieved by cooling a substance to a threshold temperature where there is no molecular activity. When there is no molecular activity, the molecules do not move, and hence you let one electron to pass through it, and automatically it starts moving. Right? It is equal to something like we have on the road, so many vehicles are moving. Okay, now what you do is you want one vehicle to move with a very higher velocity. Let us say 200 kilometers per hour. Is it possible on these roads? No, definitely not possible. Okay, you should have good skyscrapers with no in-between hurdles and so on. So what do you want to do in that case with these roads? Freeze all the vehicles. Okay, avoid all the connections, block all the connections, block all the junctions, and see to it that there is only one vehicle which runs. Recently also you would have heard in Bangalore, I think from Mandya to Bangalore, there was a heart transplantation taking place, and the ambulance moved at a speed of around 120 kilometers per hour or something. Okay, so this is what happens. So the same thing is happening here also. See, when you relate physics with the day-to-day life examples, physics becomes very easy. But if you think physics as a subject, it becomes very difficult to understand. Okay, fine. Thank you, friends, for watching this video. If you like this, do like, share, comment, and subscribe to my channel so that it gives me a lot of appreciation and I will be able to do more number of videos. Thank you.